Uh, Today we are going to discuss regarding polyamide. Okay?
Okay. Okay, ma'am.
Yeah. So polyamide, generally, it is a chemical name, this polyamide. And generally, you people are most aware of the name that is your nylon. Basically, in commonly language, or every people know that nylon. But the chemical name of nylon is polyamide. Okay? And why it is polyamide and what kind of how the manufacturing process is take place, we are going to discuss in this few coming slides. So first of all, we have to know what is okay. Okay, pointer. So the word nylon is a generic term that is used to explain or to give a family name that is your polyamide, synthetic polyamide. And this polyamide in the short form, we generally consider them as a PA. It is the first engineering thermoplastic. This first engineering, it's gave you a lot of meaning on that. Engineering means it have more application in terms in the engineering industry or the mechanical, chemical, all those kind of industry. That is the nylon is considered as one of the first engineering thermoplastic. And nylon is commercially successful or synthetic. This is the first, you can say, like synthetic polymer. Okay, first commercial synthetic polymer, that is here, nylon. And its research began in 1927 by an American company named DuPont. Now, I think it has been distributed or it has been separate. The name has been changes and it's make lot collaboration with Dow Chemicals and many others. Because this DuPont have different section. Right now, it is distributed. So this nylon, we can say it is our first thermoplastic polymer, and it is the first synthetic polymer also. You understand by the two terminology we use, you will know when you will study about your cellulose. The polymer is the origin of polymer is classified into two. One is known as your uh, we can say like natural polymer. That is your natural polymer. What are the natural polymer? Means the rubber. Okay, you saw the rubber tree. They collect the rubber, that latex liquid, and they do the cross linking, or then they got the final polymer. So the natural polymer means the monomer or the polymer directly we are getting from a natural sources. Or the synthetic polymer means, anyone can tell me what do you mean by synthetic polymer?
Is it like a hydrocarbon?
Pardon me?
Is it a compound from a hydrocarbon?
Okay. It is the compound that natural is also hydrocarbons and the synthetic is also hydrocarbons. But the synthetic polymer means that is a man-made, that is not available. Naturally, it's not occur. We provide the few chemicals and the reaction will be occur and the final the polymer will be manufactured. So it is totally think by a human person and it is done by a human person. So the human made polymer that is known as your synthetic polymer. What are the natural polymer? Natural polymer is the cellulose, hemicellulose, lignin. Okay, so these are the natural polymer that occur naturally. That is not synthesized by the human. Right now, they are synthesizing that by human, but it is naturally occur. So that is the reason they are the natural polymer. But this is your synthetic polymer. Means when this polymer world, polymer if you'll go back to 90s, uh, a polymer, they call that as a micromolecules. What terms they call as a micromolecules? What's a micromolecules? Because it is a long chain and it is continuous. We can't like specify whether mm, they will form a straight chain or whether they will form a branching. It is very difficult to conclude, okay, what kind of structure they are going to form. Sometimes we can confirm like what kind of structure is going to form according to their raw materials that we are using. But it is difficult, like those who have more number of molecular weight, 6,000, 7,000, 1 lakh also, few of the polymers are there. If you saw our DNA, in body we have DNA or protein, RNA. So all they are also come under your natural polymer. So we don't know the actual molecular weight of that polymer. So that is the reason it's quite difficult, okay, to like to know the polymer structure or anything. So it's take lot of time to manufacture the new polymer or do the co-polymerization also sometimes. So can you believe that this is the first in 1927, this is the first commercial means that come into the market. In research, there are a lot of polymers, but for commercial purpose, this is the first. Nylon is said to be the first commercial synthetic polymer, and that research is done by in 1927 by American company that is your DuPont. So how this nylon will be formed and how this nylon is synthesized or the manufacturing process. So nylon that are described by numbering system. Okay, yeah, see, we will see, you can see this nylon 66, nylon 610, nylon 6, nylon 11, nylon 12, all this naming. So that is the reason nylon is generally described by the number system. 6, 6, 610, and 6. So what are these 610, 6, and 6? That also we will know. But we have to know in which process the nylon is manufactured or synthesized. So for that, suppose if I am taking an example of the nylon 6,6, I'm taking the example of this that is known as your uh, dicarboxylic acid. Okay, any dicarboxylic acid. So if I'll take the example of nylon 6,6, so here it is the monomer that is your dicarboxylic acid. So what do you mean by dicarboxylic acid? Yeah, if you see this is one acid group, COOH. This is one acid group and this is another one acid group. So this is known as your dicarboxylic acid. So what are this dicarboxylic acid? Might be your adipic acid, sebaceous acid. So these are the dicarboxylic acid. Means if you see that any two groups at the end, they have two carboxylic acid. So what do you mean by carboxylic acid? Is this C, O, O, and H. This is known as your carboxylic acid. And this is one carboxylic acid and this is one carboxylic acid. That is the known as they are the dicarboxylic acid. And what another things we required? We require diamine. Amines means NH2. Okay, this NH2 is known as amine group. And if there are two diamine present, so that is known as your diamine. Is that clear? So this R or this R can be of like suppose hexamethylene diamine or there are different kind of diamines are in the market or the that can be if we'll go downwards there are a lot of diamine is there, so there you can know what is that this R can be. But for dicarboxylic acid this R, okay, can be of suppose this adipic acid they have four alkyl group are there. Okay, for sebacic acid, they have six alkyl group are there. So it's depend upon the different dicarboxylic acid we are using. So for the preparation of your nylon, okay, we required this monomer. So what is the basic functional group? Or see, in polymer, if you know about the synthesis mechanism or the type of we do the synthesis, okay. So there, this group is there. So this acid group is known as your functionality. Okay, if you study of the functionality while you study about the type of reaction like addition, polymerization. So what we see that these are the two functionality. This is one functionality and this is one functionality. So how much functionality? Here the number of functionality is two. So as same as your diamine, how much functionality is there? Two. Because this is one amine group and this is another one amine group. So they both are quite balanced. What the reaction will take place over here? So, can anyone from the audience, can you tell me what sort of uh, polymerization is taking place here?
Addition polymerization.
Uh, you are saying what? Uh,
Addition,
pardon me?
addition polymerization.
Addition, yeah. Or something else? Have you heard about condensation polymerization, step growth polymerization?
Yes, ma'am.
So here, the reaction it is going is known as your step growth. Okay?
Okay, H2O is coming, so it is condensation polymerization. Huh? Output like
Yes,
H2O.
yes, yes. Here, this hydrogen and this OH, they will term as a H2O. And this will be making a link. And this linkage means C double bond O and N. Here one H will be attached. So this known as your amide linkage. So that is the reason they call as a polyamide. Understand? So for that, suppose if we'll take the example of this group, what is this? Aminocaproic acid. So what this will do? See, this do not have like diamine or dicarboxylic acid. What they have in one end, you can say they are having NH2, and in one end they are having COOH. So they will also form the condensation reaction, and here they will form the polycaprolactam nylon 6. So now we will learn something how to keeping this nylon 610, nylon 66, nylon 6. So the first criteria or the first thing you have to remember that the first, suppose I will take the example of, please look into this. Okay, if I will take the example of this thing, what is this? Hexamethylene diamine. Okay, how much carbon is present? 6. Okay, only 6 carbon we have present here. In adipic acid, okay, how much carbon? Only tell me how much carbon is present in
4.
adipic acid.
4 plus 1, 5.
No,
4.
count.
6 is there.
6. This is
H2O
4, 5, and 6.
6 carbon atom.
6 carbon. Okay. And this is also having 6 carbon. So here I will write nylon 6. These 6 represent the number of carbon that is present in your diamine group. And this carbon is represented by the number of carbon atom that is present in your acid group. Is that clear?
Yes, ma'am.
Okay. If I take this example, tell me how much carbon present in this diamine group?
6.
6. And how much carbon present in this sebaceous acid?
7. 8.
8.
Okay. Sorry. Sorry, the formula here should be 8. I'm sorry. This should be 8.
Then 10.
Then how much?
10.
It will be
10.
10. So what can be the nylon name to this final product?
Nylon 6. Nylon 10.
Yes, nylon 6, nylon 10. Okay. Then how I will name to this? How much carbon is present over here?
6.
Okay. Because here in one end I have amine group, in one end I have carboxylic group. So they form in the ring. So we have a different reaction that is known as your ring ring opening reaction. And in that, these two will be release the H2O, okay, and they will form you step growth polymerization. Understand? So in this, we only tell they form nylon 6. Okay. The same thing I have wrote over here. The chemical structure, nylon may be divided into two basic types. Those based on diamine and dibasic acid, or those based on amino acid or lactam. So here are the two types of groups. Just give me 1 minute. Okay. So that that naming means we give this chemical structure name on the basis of if we have a diamine and acid, or when we have a amino acid or lactams. Okay. So in this two way we can name the uh, uh, nylon chemical structure. Is clear to everyone? Because this will decide all your properties. So if you see this,
Which will decide our properties? Sorry, which one?
this raw material, the monomer that we have now, they only decide the property, and they will decide the what kind of structure this polymer is going to be take place.
Yeah, basically monomer means hexamethyl
Hexamethylene diamine or this
adipic acid.
means dicarboxylic acid, diamine, and these are known as your amino acid or lactams.
And also adipic acid also, right?
Yeah, that will come under your dicarboxylic acid.
Okay.
Right.
Yes.
Now, question is, if acid cannot be called as monomer, no?
Yeah, your acid and diamine both will come call as your monomer.
Acid also we can call it as monomer.
Yes, these are because these are the two monomers, and from monomer you are getting the polymer.
Okay, okay.
Yeah. So you can see these are the application of nylon, very colorful, and but nylon it's look like this. But the nylon have a huge demand in industry for the fiber production. Okay, and for many some nylon we will see in the coming discussion that they can replace the metal also. Okay, they have that much strength. So can you imagine that nylon is switching its property from this fiber to so strong uh, metal-like property? So that's all because of the final structure of the nylon, uh, how they manufacture. Okay. Generally, this polyamide is classified into three terms. That is the aliphatic, semi-aromatic, or aromatic. You all know what do you mean by aromatic?
No, ma'am.
So aliphatic is just linear. Okay, suppose you have CH2, CH2. They are in the linear form. Or aromatic means they have a cyclic structure, or that is consist of your benzene. Okay, heptane means when you have this benzene ring, that is known as your aromatic. Is that clear? or when you have a strong chain in the sense, or when you have a straight chain that is consist of any kind of molecule. Suppose if you have CH2, C, double bond O, N, H. So this is when they are not in the in this shape, they are fully in the straight line. They are known as your aliphatic, and aromatic means they have a cyclic structure. Cyclic structure with they have double bond. They have this kind of structure. Okay, they have here not double bond. This will be formed like this, and here you can have C double bond O, and here we have N H. So these are your aromatic polyamide, and these are your aliphatic. So which come under your aliphatic? Like nylon 6, nylon 6,6, nylon 11, nylon 12, nylon 6,10, nylon 4,6, nylon 6,12. So these are the nylon, they come under your aliphatic. And polyethylamides, PPA, that is known as your semi-aromatic. Means your aromatic will also there, but simultaneously you have a chain structure. So that will be come under your polyethylamide. And what will come under your aromatic? Aromatic is like p-phenylene terapamide, polyamphényl isothylamide, polybenzaimidazole, PBI, aramides. Aramides, we will see in the later on section, this aramide have a very special characteristic. So we will try to cover the very importance of this polyamide and the important polyamides that is commonly used in the market. So this is the general classification on this. The polyamide has been classified. Next. Here will be the general introduction to the aliphatic and semi-aromatic or the aromatic amides. So this polyamide 6, for that I required the monomer that is your caprolactam. Okay, and if you saw this is the structure. Okay, aminocaproic acid or the caprolactam. Laurel lactam for synthesis of your polyamide 12, you required your laurel lactam. Then for polyamide 6,6, okay, you required this is your diamine. So what the diamine you required? Hexamethylene diamine, but the acid here I changes is my adipic acid. For hexamethylene diamine, that 9 will be your azelaic acid. Azelaic acid. So for polyamide 610, okay, we require hexamethylene diamine and 112 dedanoic acid. Can you see if I changing the 6 is constant here from this polyamide 6,6. The 6 is constant because I'm using one kind of diamine. If you see that diamine is constant, okay. So hexamethylene diamine, and hexamethylene diamine. So if I see that, these are constant. But if you see like 6, 10, 12, here you have your the acid group is changing, due to which here I can find the change. But this polyamide 4 6, okay, that is known as not 4 6, we can say here as your this 1,4 diamine no butane. This is one kind of your diamine, 1,4 diamine butane. Butanes means 4 carbon. Okay. And adipic acid. Adipic acid has 6 carbon. That is the reason 6. Next, we have polyamide, uh, 12 and 12. That is known as your 12 dedocanide diamine and 112 dodecan dioic acid. So these are the few of the naming of your aliphatic polyamide polymers and their monomers. Is that clear? But the two most widely used polyamide, see, these all are can be used or it can be available in the market. But if you look into the application wise or the generally that using in the market is maximum your polyamide 6 or this polyamide 6,6, polyamide 12 or polyamide 11. So these are the few polyamide that is commonly used in this market. Okay. So that I told you PA66 or PA6 that is widely used. And how can we do the fabrication to this? They are often extruded, means by using two like twin screw or multi screw or the single screw we can manufacture the fiber and that also into a particular diameter because in the fiber the length is quite long as compared to the diameter. So this polyamide 6,6 and polyamide 6, they are oftenly extruded to manufacture the fiber that is generally used in your textile industry. Or we can use that for your film packaging or injection molded grade polyamide 6,6 and polyamide 6. These two that is known as your nylon 6,6 and 6 also. So they are generally amorphous or semi-crystalline or uh, higher crystalline. So it's always depend upon the final structure. As I'm telling from the very first class also that any kind of polymer, how they form in the final structure, that only decided whether they will form your amorphous, semi-crystalline, or greater crystalline, or the lesser crystalline. So if you see this, nylon 6,6 is much like they come under higher crystalline. Okay, that I will tell you also because they are having a very linear structure with highly close packed. Okay, so that is the reason they are having a quite packed structure and they are having higher, greater amount of crystallinity. Uh, if you see that all those nylon, okay, uh, they have a what can I say? They have a limitation, or they can have a problem that is known as moisture absorption. So this nylon, okay, I'll tell you why they have that.
In the starting, you told man-made and natural monomers.
Mm.
Here, which one is natural and which one is man-made, ma'am?
I told you, in nylon, all are man-made.
All are man-made only. Even
Yes,
this hexamethyl amide also, it's man-made only.
yes.
Okay, okay. And these things are coming from is what is the input of this is hexamethylamine?
Pardon me, what is the input of
From where
hexamethyl
it is,
diamine?
what is that input from where it is coming hexamethyl amine?
Yes, yes, it is a chemical only,
Okay.
hexamethyl diamine. You can directly purchase. They are coming like that only. Okay.
It's in liquid form, huh?
Yeah, it is in the liquid form.
Okay, ma'am.
Yeah.
And acid is already liquid, so both liquid forming a solid substance.
If your acid molecular weight is quite high, so definitely they will come in the solid form
Okay.
because of the viscosity issue. Okay.
Here in our example, both are liquid only.
Adipic acid is in the liquid, but sebacic acid is in the solid form, white powder form.
Okay.
Yeah.
Caproic acid ಅದು.
Aminocaproic acid, they will come in the liquid form.
Okay. Okay, ma'am. Thanks.
Yeah. Okay, what I'm talking is that this nylon have a limitations that they absorb water very quickly. Okay. So why they absorb the quickly? Because of presence of this amide linkage. This amide linkage is quite polar in nature. So they try to always attract toward the water. That is the reason here this amide have a problem, or this diamine or this dicarboxylic acid. Okay, when they form this amide linkage, they easily absorb the moisture. Understand? So remember one thing, whenever you process any nylon, any grade of nylon, it should be pre-dry. Okay. Otherwise, the moisture present in this nylon can give you the bluster, or it can give some other watermarks also in your final processing part. But once these nylon are processed, okay, means whatever the final product you manufacture, once they process into the final product, then they will be moisture stable. But when they form, suppose they have a nylon 66. So this nylon 66, due to this present of this amide linkage, they are quite moisture sensitive. So they will easily entrap the water molecules. So it is always recommended that whenever you will use nylon for your manufacturing, it's better to pre-dry them before you are doing any kind of processing. Okay. So that is the reason here I give you one chart. This nylon 66, if you see that the water absorption, they calculate according to your ASTM D570. This is the one method to know the water absorption, how much water that absorb in that particular polymer. So if you see this nylon 66 and this nylon 612, not sorry, nylon 6 and nylon 66, they are having quite high amount of water absorb. as compared to your nylon 6,8, though not they didn't have any data. This indicate they didn't have the data, or they are quite low in the water absorption. But this nylon 6,6 and nylon 6, they have a quite high amount of water absorbed in that. And the melting point of this nylon 6, suppose if you see the 6,6 is 265. That is the reason whenever you will use nylon 6,6 for your manufacturing, you have to do the pre-drying process to it simultaneously for your nylon 6, because they have also the melting point of nylon is 2 to 6 degrees Celsius. So if you see that how your this structure of the acid group is changing, or how we are increasing the carbon content, means I want to say you that, can you see here first 6 carbon, then here your carbon amount is 8, uh, and this all represent the what, this all number represent which group? Tell me. These represent which carbon group? This represent your dicarboxylic acid. This 6, 10, okay. They all represent your acid group carbon. So if you see this, when there is an increment in the acid group carbon, you see the melting temperature is decreasing. This melting temperature is decreasing just because when the acid carboxylic group is increasing, so the compactness between this carbon is lesser. That is the reason you saw the melting temperature is also decreasing. Okay. And we can see nylon 6,6 and nylon 6 have a highest amount of water absorption. Okay. Then we will know like how this nylons, we will study more into of nylon 6 and nylon 6,6. So this nylon 6 or this polyamide 6 is also known as your nylon 6, or that have another name that is known as your polycaprolactam. So if you saw, they told you about the polycaprolactam, means they also known as your nylon 6. If they are telling nylon 6, means that is also known as your PA6 or polyamide 6. So all these have same meaning. Nylon 6, polycaprolactam, or polyamide 6. They all three are one material only. Okay. So if you see, this is your caprolactam structure. We heated them in 533 to 543 Kelvin, and here it should be minus H2O. What do you indicate by minus H2O? Means your water will be removed. Okay, water will be removed from here. So this is your caprolactam, means here before you have NH2 and you have COOH, that is your carboxylic group. So from here, this I can write in this way also. This I can write in this way. This is one hydrogen and here one hydrogen. So this H2O will be removed in the form of water, and we have NH and C double bond O. This is known as your amide linkage. That is known as, this is whole known as your nylon 6 or polyamide 6, or we can call them as a polycaprolactam. Is that clear? And it is one of the most extensively used polyamide globally. Means this polycaprolactam or this polyamide 6 or nylon 6 have a huge demand in the market, and they are most used polyamide. Among you have polyamide 6, this 6, 12, lot of we have seen just right now also. Among these, this nylon 6 or this polyamide 6 have a huge demand and most used polymer in the market. And it is synthesized by this ring opening polymerization because they are in the form of ring and they open it and they start the reaction. That is this known as your ring opening polymerization of caprolactam. Okay, this is your sorry, this is your caprolactam. You can't see another here. It can be of like OH will be, and this is known as your mm, uh, removal of that. Means here we can do the ring opening polymerization to got this nylon 6. Here the melting point of this polyamide is how much? 223 degrees Celsius. So what is the Tg value is 47 degree Celsius. Means below 47 degrees Celsius, these polyamide 6 were quite brittle in nature. Above this 47 degrees Celsius, they will be flexible in nature. Next, we will study some related to your polyamide 6,6 or that is known as your nylon 6,6. It is also one of the most popular engineering thermoplastic. Okay, this is also one of the most popular engineering thermoplastic.
Ma'am,
And it is, yes,
one doubt. In the first one, C double bond O and CH2 5 hyphen N and H is there, no? If
yeah,
it is amide group will always attract moisture content. If moisture is
yes.
the oxygen will go off, or what will happen? How the degradation happen normally in this structure?
Okay, what in the structure? First, what you want to saying me if moisture is present, how that degradation it's occur in the nylon 6. You are
Uh,
saying me that?
yeah. As a structure, how it fails?
Okay. See, the structure will not fail. Okay. First
Hmm.
of all, due to the presence of water, you can get lot of carbon dioxide which will be released during your processing. Okay. It will be not break your structure. Okay, but lot of byproduct that will be evaporate. Can water sustain to 200 degrees temperature? No.
Uh-huh.
Okay, so that water and these they will convert into the vapor or in the gaseous form. So due to that, you can in your final product you can get some of the marks, different marks, or you can get some blister like structure like this. So
Air,
that is the
air
yeah,
bubbles, we call air bubbles. It's like air bubbles, huh?
yeah, air bubbles, right? Absolutely correct. We call that as a blister.
Okay.
Okay. So to avoid that, okay, because if that air bubbles will be there, then what will happen? That look wise, so it is not good. somehow that part particularly can affect your mechanical property also of that material. Okay, so that is the reason we have to be cautious while using this material. We have to do the pre-dry. So the all the moisture and everything will be removed and you can do your processing quite smoothly. Okay.
Okay, then as structure there will not be any change, but maybe we have to get some volume. Now the volume will be reduced because of this dip.
Yeah. Yes. And some other thing also happen. I can't tell you, but it can affect your final product mechanical strength also.
Okay,
Yeah.
physically by structure, chemical structure there is no change, but mechanical.
No, no. Yes, yes.
Okay, ma'am. Thanks.
Yeah. So this polyamide 66, that is or nylon 66, it's one of the most popular engineering thermoplastic. It is a majorly used to replacement of metal in various application. Okay, we will see in the later on section like why we called this nylon 66 is also known as for your replacement of metal. Okay, that we convert that or we can replace the metal property also using this nylon 66 in quite many applications. This nylon 66 is synthesized by a polycondensation reaction, that is your hexamethylene diamine and this adipic acid. Okay, so we will get nylon 66. These two monomer contain six carbon. As I told you, why this naming is nylon 66? Because this six carbon is belongs from this hexamethylene diamine, six carbon, and this six carbon is from like 4, 5, and 6. It is belong to this adipic acid. So it has a greater melting point from your polyamide, that is 255 degrees Celsius, and the TZ is 70 degrees Celsius. So this nylon 66 is quite thermally resistant, or I can see they are heat resistance because the TG also quite high and the melting point is also quite high. This just I gave you like how this manufacturing process for this polyamide 6 or polyamide 66 is took place. So if you see, this is your, this is just the, I gave you just a schematic diagram. Okay. So don't be confused like what is this and this. This is just a schematic diagram how in industry the PA6 and PA666 manufacture. So in one container we have both adipic acid and hexamethylene diamine, and that will be come over here as we are doing them in a high temperature. So we use this water evaporator or this reflux condition so that all those system that they can maintain over there without evaporating any of the chemicals. Then that we give into the autoclave because we need high pressure as well as high uh, uh, temperature. Then we pass that material into this water chiller and we do the washing. Okay. So all those unreacted acid or unreacted hexadimethylamine that will be soluble or that will be come with the water, and then we take that into the cheaper and then we do the spinning solution. Means this is generally we do for the fiber production of the nylons. So here we can do two methods like spinning continuous filaments or spinning staple. air cooler will be there, and there will be a meter and pump, so you can collect that. So what will happen there? Air will cool and the individual filaments. What do you mean by the filaments? It is the individual thread, okay, individual thread of that particular nylon. So that will be collected by this spindle. This is known as your spindle, okay? That will be collected and it can be turned over, twisting, and that it convert into your yarn. Yarn, it will be convert, then it will be finally collected over here. And that we do for this. For undrawn tone, what they will do? They will fix them into the roll, okay, and here they will do the clamping or they will provide the heat, then they cut it into small pieces. Okay, so you can got like they will come under this kind of small beads or small kind of uh, ballet that is known as, okay. And here you can got directly the thread one, but you got the chopped percent of your thread. Then you take them as per your application. What then if we receive I will talk a few things regarding your processing consideration. Means suppose while you process this nylon 66, okay, this nylon 66, uh, see, it will be formed like this in the form of your yarn. Okay, this they have a huge application in the textile. I think you all have seen the nylon clothes. Okay, so this will be into the spindle. So while I will do the processing of this nylon 66 in any processing that might be of injection molding or extruder techniques or compression molding, I can do the foam molding also, rota molding also. So what take care should I take? First of all, this polyamide are heat sensitive materials. Means why they are heat sensitive material? See, the presence of this group, okay, if as I told you for which polymer that I have discussed, polystyrene or polycarbonate, as I told, they can sustain to that much heat. But if I keep that material in that what we exactly use the term, if that polymer stay uh, contact time, okay, the contact time of this polymer in your processing techniques, okay. Suppose if I am using the two roll, okay, I have a I have a this is the barrel, okay. So if I that material, it should not be contact to this barrel for a longer period of time. That is the reason this polyamide, due to the presence of this carbonyl group, okay, this is we called as a carbonyl. What will happen? This will be broke down, okay, due to the presence of this pi bond and this sigma bond, okay, they will break into two parts and those free radical will be created. So that is the reason this polyamide are heat sensitive material. So here we can use the additives is known as your heat stabilizer. All kind of heat stabilizer you can use that. TiO2, different kind of heat stabilizer that is generally available in the market. So for processing of polyamide, we can use your heat stabilizer as they are heat sensitive material. This polyamide 66, also processed in the temperature between 260 to 320 degree Celsius. Okay, this is your processing temperature. As I told you, materials, this nylon material are quite prone to this moisture. That is the reason this material has to be pre-dried at 80 degrees Celsius. How much? 80 degrees Celsius for 2 to 4 hours prior to your processing. Okay, to remove all the moisture that is accumulate in the surface of your particular nylon material. And the annealing temperature of polyamide can be of 149 to 177 degree Celsius. And this have we can do this polyamide 6,6 or this nylon 6,6 can be, we do the injection molding of it. We can do the extrusion techniques. If we use the extrusion techniques, then they will, you can form them into the pallet form, and that pallet, or we can prepare the master batch also, and that can be further used for this injection molding, or you can supply them as a raw material. We can use for like compression molding also, we can do the nylon 6,6 or this foam molding and rotamolding. So if you see this structure, can you tell me what is this? Where you saw this application?
Splines.
Yes. So this is made of a pure nylon 6,6. And it gave a comparison, or we can say they can replace the metal. And here I have a frictional bearing. Okay. If you see that this is your ring, okay, inner ring, and this is your outer ring. In between that, they in this reason they apply this nylon 6,6, and this also they apply the nylon 6,6. And you know, if I here the small ball will be there. So or this ball is also connected to this nylon. This they apply for more durability. Durability will be high, no corrosion will occur, and the sustainability of the material is quite high. Next, what kind of grade of uh, polyamide 6 or the nylon 6 we can have? They are available in 6 various grades. And these all grades are always, see, here I am giving you only the four, sorry, not six. This is the four. Okay. This four is as for my knowledge. Okay. So I don't know, many industry, they can like manufacture nylon 6 according to their application, and they can have more grade. Okay. So just for my information and my knowledge, I just, for example, for you also, this is one is injection mold graded. Why we just because this injection mold graded is only you can apply them while doing the processing of injection molding only. Then we have a extrusion grade. Then we have a rotamolding grade PA6 or fluidized bed coating grade. Okay, so these are the different four grade of polyamide that is available in market, but you have more than this also. This is not only constant to four grade, it have lot of grade like flame retardant nylon, moisture resistance nylon 6. So different kind is there. They do some of them. They will do the copolymerization, or they will do the add the additives to for as per their own requirement. So, if we do the processing to the nylon 6, what are the things we need to take care of it? First, as I told, they should have a pre-dry. As like your nylon 6, nylon 6 will also pre-dry for 2 to 4 hours, okay, before you will do the processing. And these are the few terminology or the few characteristic we have to be remember while doing the processing of polyamide 6. First, if you are doing in the injection molding, so the injection speed should be high of the molding machine. Try to keep the see, this is on behalf of my experience, I'm saying that, okay, but again it will be differ if we differ the grade of the polyamide. It is not always constant. So for high injection speed is required, then we have to control of sorts and size. Okay. The raw material size should be small. Okay. If they are coming in the pallet form, so the pallet should be in the smaller in size, and the quantity we are using as a pit stock for the injection grade that should be also we have to be checked properly. Then minimize drooling by nozzle tapper tap. Can anyone tell me what do you mean by this? If anyone have a processing of injection molding,
Means if we are
drool.
molding some component or article, the size should be means the article should be filled full, not short size
Ye-
or incomplete molding and all.
Yeah, yeah. That you are absolutely okay with this. I'm talking about this. Minimizing drooling by nozzle tapper type.
Uh, Means if we are doing some injection molding,
Hmm.
sometimes it happen that the material which is fed into the barrel that is drooling from the nozzle end due to
Yes,
high temperature or
yes,
due to the melting temperature may be high of maybe low of that material due to that. So we need to
yes.
control that drooling with reducing the temperature of the nozzle and all.
Yes, we need to see the viscosity also. Okay, if that are higher molecular weight, so viscosity will also higher. So we need to control this nozzle drooling. Okay.
Ma'am, is it sprue diameter you are telling or nozzle? Nozzle is next to the barrel, no? Sprue comes inside the tool, and from this sprue only this drooling is to come, no? Cavity side.
Yeah, but I'm talking about nozzle, not about sprue.
Used to have this taper inside.
Yes.
Because nozzle we used to nozzle dia should be lesser than sprue dia. That is what we used to see for to match that center. Other than that, we never saw core taper.
Yeah, but we have to control because this nylon, okay, the little bit the molecular weight and temperature is high. So we have to minimize the drooling of the nozzle there.
Okay, okay.
Yeah. Then due to you can find some other like shrinkage of the part. Okay. So you have to take care of this processing because nylon 6 you can see the shrinkage. Okay, this kind of shrinkage which also you can find in the part. So that also take care properly. Then this annealing we do by 130 to 140 degrees Celsius for 10 to 12 hours. We will study few of the
What is the meaning of annealing?
annealing means of when we do the heating. Okay. Annealing means when we do a proper increment in the heating process. Means suppose what I told you that TG, how much TG of nylon 6? It is be 40 degrees
47.
Celsius. That is. So suppose if we are increasing the temperature, okay, because we have to increase the temperature in a stepwise. You know that in the processing we can't increase the temperature suddenly. Okay. So there we increase the temperature stepwise until they reach a soft point. So the increment of this temperature is we have to do from this.
Actually, in our company, we do annealing. It's a post injection molding process.
Huh?
After injection molding, product will be hard, little harder, and it will tend to crack if a load is applied. To soften it
Yes.
like metal, this annealing is done.
Yeah. For the softening.
Yes, ma'am. Yes, ma'am.
Yeah. So generally the annealing process is a heat treatment that we do for softening that we do for the metal also. Okay. And for the polymer also. Both the things to improve their toughness and ductility. Is that clear?
Yeah, ma'am.
Yeah. So we will study few of the properties of this nylon. Uh, and this nylon means I'm talking about all the nylons. We have few of other nylons also to be discussed in the coming few slides. So here I will talk about some aliphatic polyamide. They have excellent resistance to wear and abrasion. Means this nylon weight loss will be very less when they come in contact with the frictional forces. Okay, or abrasion means when they rub with each other, okay, the mass loss will be very less. So they have a this nylon have very excellent property of resistance of this wear and abrasion. So that means what? This nylon have a quite sustainability, and they are having a very good flow. As I told you in the polystyrene case also, uh, this good flow wherever we consider, then that is very easy for the processing because they can easily come out from your particular processing uh, processing equipments into the mold, and they have a good resilience and high impact strength. This resilience means a material sustained how much load without any plastic deformation, without any final failure, how this material sustain the load. And this impact strength is also quite good in the term of nylon. That is the reason we are using this nylon in your fuel tank. Okay, this is basically, if I'm correct, this is your fuel tank, right? So here we use for that due to this few of the properties, and they have a good balance of high strain as well as elasticity, toughness, and abrasion resistance. Because if you see many polymers, if they have high strength, then the elasticity will be reduced. Okay, but if they have high elasticity, then the strength will be reduced. Or if they both have, then the abrasion resistance will be low. But this nylon have a very good balancing features of your high strength, elasticity, toughness, as well as your abrasion resistance. They maintain a very good property at elevated temperature. Means when the temperature is increasing, then you find they are quite stable. The mechanical strength is stable because they are having a high amount of Tg. So when we increase the temperature, still they maintain a good mechanical property, as well as at low temperature, they retain the flexibility and toughness. So when you increase the temperature, they maintain the mechanical strength. But when you decrease the temperature also, they are quite flexible and toughness. So what happened when we modify this nylon of various grade are produced by, as I told you, in the case of your styrene also, okay, or in the case of your carbonate also, we produce lot kind of variety of this polymer. How we do? By doing the copolymerization or the incorporation of various additives. Okay. Like addition of less than 1% copper salt, they are quite good heat stabilizer and permit us for nylon at elevated temperature. If we use 1% of copper salt into the nylon, then they are quite heat stabilizer, and that nylon we can use for your elevated temperature. Okay. All the nylon clothes we wear, okay, uh, if they catch fire, then what happen? Whether they melt or they form into ash, or what thing you observe,
They melt.
they melt. Okay, so nylon, they never burn.
Ma'am, your voice got cut.
Then next thing is that, okay, we will study some application. Am I audible?
Think frequently, ma'am.
Pardon me?
Your voice is getting cut frequently, ma'am.
Okay. Am I audible now?
Yeah.
Yes, ma'am.
Okay, just please. Okay, so this application we have, we use this nylon
in the gear, bearing, and bushing or cams. Why? Uh, because they have a high tensile or impact strength, due to which their toughness, lubricity, and low coefficient of friction. Due to this property, they have this application in your gearbox, bearing, bushing, and cams. Due to the high strength and corrosion resistance, okay, they have a application. We can use them as a screw nuts and bolts. Okay, if you saw that plastic one wala like nuts and bolts, so they are generally manufactured from your nylon 6/6. Okay, why? Because this nylon have a high strength and corrosion resistance. Then due to the low permeability to water and air, to preserve freshness, they are high strength puncture resistance, due to which we use them in the food packaging also. Resistance to another application is that they are using for the coating of wire and cables, because they have a resistance to stress cracking, abrasion, and corrosion, and they are the low moisture absorption. Means this particular application, it is applicable for your polyamide 12. Okay, or the nylon 12, they have this particular application. We will see after 2 slides over here. Okay, so here according to this property, nylon property, they have this particular application. And these are the few physical property, okay, that nylon have. Like the tensile strength is from like 90 to 185 Newton per mm square. Notch impact strength is like 5 to 30. Uh, okay. Then this thermal coefficient of expansion is also quite low, and that is very good. The reason with them we use them in your bearing. Okay, because the thermal coefficient of expansion, it should be low. Otherwise, due to the heat transfer, they got expand, and it can cause the like failure of your machine, because they expand, then your rotation will be stopped. That we generally see while if you using the two-roll mill at very high temperature. Okay, maximum uh, constant use of this temperature will be 150 to 185 degree. Density will be in the range of 113 to 135 gram per centimeter cube. And these are the this I gave you this symbol is to like how they are resistance. So the nylon was quite not that much resistance to your dilute acids. Okay, like if you have one normal HCl or two normal HCls, so this nylon are prone toward this acid, and your polymer may be degrade. Dilute alkyl, they have quite sustain resistance to that. Oil and grease, they are quite resistance to oil and grease. That's why we are using this nylon in our gearbox, or we are using the bearing also. Aliphatic hydrocarbons, yeah, they are quite applicable for hydrocarbons. They are resistance to this. Aromatic hydrocarbons also, they are resistance. Halogenated hydrocarbons are, it's depend upon like what kind of halogenated hydrocarbons we are using. Alcohol, they are very like if we use methanol, ethanol, or isopropyl alcohol, they are registered, but it's depend upon what type of alcohol you are using. As I told you, as like other polymer, this nylon have also certain limitation. It can melt easily, as I told. It is a type of plastics, and nylon can cause infection, as nylon have few connection with the moisture. So this nylon can cause infection. Nylon, and this infection is because this nylon have a barrier properties. Okay. What do you mean by the barrier property? Means if you, okay, I will tell you in this way. Barrier property means the it show you the permeability. Okay, the air is not come inside this, because this nylon will show a restriction to enter this air. So suppose if you wear a cloth made of nylon, you can feel that you feel irritated after some times, because as compared to the cotton clothes we wear, generally the air is easily transmitted, or it can be easily in the ongoing passes. So that is the reason we feel cool, or we feel very comfortable on that. But this nylon have this barrier property of the air. That is the reason we feel uncomfortable, and that can lead to be the reason of infection, because if the sweat because this nylon will not absorb this sweat also. So the sweat may cause the microorganism to growth, and that will be lead for your infection. Nylon is somehow the temperature resistance up to, suppose if it take about 240 degree Celsius, but they are not heat sensitives.
Ma'am, what is that infection we are talking about?
Pardon me?
Infection. Infection means what type of infection?
Infection means you can have a skin irritation, if you can have some kind of fungal infection, that kind of thing.
Okay, for the operators or the users.
Yeah.
In the material, there is no defects. It's not defect.
No, no, no. In material, there is no defect, but that material act as a barrier. Barrier means the air will be not come in flow to that material, na? So
Okay.
what will happen if you wear the clothes for longer period of time? We got sweating. Okay, many different things are there. So it
Okay.
should be properly dry. Okay. But if your air will not come inside, if that will be restricted, so what will happen? The sweat inside, the sweat in your body will let the growth of the microorganism.
Okay, okay.
Then we have this fungal infection or anything. We got a irritating. Okay.
Yes, yes.
Yeah.
Okay.
Then we here I gave you just like a few of your this is normal nylon, means this is your nylon 6 and nylon 66. I gave you a comparison chart between this. If you saw that they have a quite lot of difference. Okay, here also I gave that the nylon 6 have less crystal as compared to this nylon 66. Okay. And they have a this heat deflection temperature, means this nylon water absorption rate.
Okay. Uh, this water absorption rate will be high in nylon 6 and it is low in nylon 66. Am I audible?
Yes, you are audible.
Okay.
Yes, ma'am.
So this chemical resistance to acid also, this nylon 66 is quite good as compared to your nylon 6. And if you see this, the tensile strain, the mechanical strain of nylon 66 is quite uh, high as compared to the nylon. And the mold shrinkage, okay, as nylon 66 molecular weight is quite high, so that is the reason we saw lot of mold shrinkage as compared to your nylon. And in case of recyclability, this nylon 66, due to the high mechanical strength, it is difficult for the recycle. Basically, we will do the mechanical recycling. So, this nylon 6 have a better recyclability as compared to your nylon 66. I will look into this polymer that is known as your nylon or PA11 or nylon 11. This is it is a bioplastic, is an odd to the nylon. It is difficult because all nylon are uh, quite they are registers, but this nylon 11 is very specific and it is quite costly also. They are bioplastic and it is produced by the polymerization of 11 that is known as amino decanoic acid. It is the monomer from where we got this structure, okay, and that is your nylon 11. And this acid that we got from castor beans, okay, the castor oil where we got the castor oil. From that bean, we extracted this aminodine decanoic acid, and this is done by Arkema. This is one company under the trade name of Rilsan, and that we used for this coating, as I told you, they can use for this coating. Okay, and this is nylon 11 coating we can do, and this kind of 3D printing also we can do by using this nylon 11. And this nylon 11 is available in the market in the form of powder. And these have lot of advantages, like they are low water absorption nylon as compared to nylon 6 and nylon 66. This nylon 11 quite low absorption, means water absorption, and they are resistant to various chemical, including your hydrocarbons, ketones, aldehyde, fuels, alcohol, oil, or mineral salt and detergent. They has a very minimal environmental footprints, means they are quite resistant to the environment, and but they have limitation is they are quite costly related to other nylons, and they have minimal heat resistance. We have another nylon, that is your nylon uh, 12, and that we got from 1,2-amino duodecan acid. Okay, here they will do the H2O will be released, and we got polyamide 12. Here, if you'll calculate, they have 12 carbon into that, and that is the reason aminoloric acid. This is known as your aminoloric acid or 12-amino dodecanoic acid also. It is also made from ring opening polymerization of laurelactam at 260 to 300 degrees Celsius. It has a melting point of 178 to 180 degrees Celsius. As compared to other nylon, this is very low melting point is this. and the density is 1.5 gram per centimeter cube. Here, as like nylon 11, this nylon 12 also have low water absorption facility, and they also quite resistance to oil, fuels, or this hydraulic fluid, grease, salt, solvent, and water. And they can accept higher loading of filler. Suppose if you want to add some heat stabilizer or something else to increase the property of this nylon 12, so they can sustain to quite higher loading of filler. And this nylon 12 have a very uh, effectively noise and vibration resistance. Means they can use for the noise and vibration attenuity resistance proof. And they are highly suitable for processing as compared to nylon 11, nylon 12 can be easily processed. As these have also limitation like cost is quite higher as compared to other nylon and the heat resistance is quite low. Here I compare like a few of the mechanical properties of this here it should be like this will be nylon 2 and it will be nylon 11. Okay. So here I'll compare like this and this. So the melting temperature is if we do by 20 degrees Celsius per minute, this is the ISO standard, or and this will be have like PA11 have a high amount of melting temperature as compared to your PA12. Flexural modulus, okay, that is in the megapascal. This PA12 have this flexural modulus, but PA11 do not have. Uh, this Charpai impact strength, that is in different. You got like 4.8 or 7 point. This is 7.8, okay, and this is the like
Ma'am,
And
this
both the Sharpie
fluctu-
impacts and
it is
hello,
different. Huh. Hello? Yeah,
uh,
tell me.
this fluctual modulus you are talking about PL12, no? Is it so
Yes.
flexible? This material is flexible, huh?
Yeah, this material is flexible, PA12.
But PL11 is hard material.
Yes, they are quite hard.
Okay, okay.
Yeah. Yeah, this Charpai, this is sorry, huh? This is not okay. Just
I think this
concentrate
one is
on
Sharpie and notch impact.
this one, no? No.
Yeah, ISO 180.
Yeah, that is some error from my side, okay, regarding this. And this tensile modulus, we have more for like as these have more flexibility. So these have 1650 and this have 1600. Tensile strength is also they are quite similar. There is no that much variation. Elongation, if you see this, have more higher elongation and sore hardness. Okay, that is according to ISO 7619. They both have similar. But I think this PA12 help limited range up to 80. Okay. And which nylon, if you see that, this just I gave a comparison for your understanding. And for operating temperature range, it is quite excellent for this. Okay. And the price is PA12 is little bit cheaper than your 11.
Flexibility, you told P11 will be hard because it was hyphen in the last slide. Here it is excellent, it is written. Flexural
Uh,
modulus.
sorry, the flexural modulus is different now. That is not that much. That is not related to your flexibility.
Okay, what is flexural this thing modulus?
See, the flexural modulus you will study in detail while you will study the mechanical properties.
Actually, what we study about in this? Any one line?
Actually, if you
Yeah,
see uh, uh, after molding some specimens, like if you see as per tensile modulus ISO 527, specimen will be there of size 80 mm length, 10 mm width, and 4 mm thickness as per ISO. So in the UTM, Universal Testing Machine, bending that
material.
bending the part from the center, it give you the flexural strain and flexural modulus value. Means how much percentage we are bending. Like as per ISO, we will do around 3.5% bending. So in that bending, how much the value is coming? That is flexural modulus.
Don't require to bend that.
Yes, that is a 3-point bending
Okay,
test we do. Two
okay,
end, two end will be there, and in the middle also you do that as a U kind of shape or C. C
okay.
if you see that.
Here, if the value is there, it is hard then. Flexural module value is there, so it is harder. In P11, not able to measure, that's why it is soft.
Yes, I
Yes.
can't say the soft and hard we can't say here. Okay, if I bend that material, okay, how much energy is required me to bend that material? That we do, the flexural modulus.
Okay, okay,
Yeah.
okay, thanks.
But when you release the force, it will be again into the straight position.
Okay.
Yeah. So we have a very champion, we call this armite fiber. I think this is very important. So the term armite is used to describe the aromatic polyamide, which were developed to improve the heat and flammability resistance to the nylon. Armite is a very important nylon, and this is aromatic nylon. Okay. And this have a trade name is given by your DuPont that is known as Nomex. Okay, this is highly heat resistance nylon, and this is introduced by this DuPont in 1916. It is produced by the solution and interfacial polymerization of isothallyl chloride. That is this. Okay, thiol. This is the thiol group. Okay, and M-phenylidene diamine. This is your M-phenylidene diamine, and this is known as your armite, okay, or aromatic nylon, and this is company name is Nomax. It look like this. And if you saw this kind of suits, that is for the fire safety they are using. Okay, the fire safety people they are using this, and this has a very good heat resistance. And this Nomex has a melting point about 365 degrees Celsius and is virtually non-flammable. That is the reason this kind of cloths is manufactured by this Nomex fiber, and they are quite flame resistance. They will not flammable. Okay, so if you see this kind of gloves, many company they use that. Okay, that is produced by the Nomex. Those who work on the metal industry, okay, they use this kind of gloves. Okay, they you can see this black color one, the char will be formed, means the carbon little bit black in color, that is the carbon, but they will not burn. So in metal processing industry or where the high temperature is needed for any kind of processing. So this kind of gloves is used, and this gloves is manufactured by this Nomax. Okay, and it has a huge application such as protective clothing, hot gas filtration equipment as a substitute of asbestos. Okay, these driving shoes or driver protection or these firefighting officers or those who are going to just protect the means they who are working in this fire protection people, they wear this kind of things to just to protect the fire. Okay, or this filtering uh, okay, where we do this hot gas filtration, that also material that we use, or we can prepare some Nomex composite also for the advanced application. Another armite that is known as your Kevlar. Okay, I think you all heard about this Kevlar. This is a corresponding linear aromatic polyamide from your terephthalate chloride. Okay, the same material over here. Okay, but here we use this phenyldiamine and we produce this, and this is known as poly P phenylenediamine terephthalate amide. That is, this is Kevlar is known as the trade name. Okay, and which decompose only above 500 degrees Celsius. If you see, these are the fiber of Kevlar. Okay, and this Kevlar used as a composite for your aeroplane manufacturing. Okay, this provide the fiber material which stronger than the steel and one-fifth of its weight. What do you mean by that? This Kevlar fiber, the property that it's carrying, it is stronger than the steel, but steel have more weight as compared to your armite. So this armite is very light in color, very light in weight, as well as, but the strength is that is more than the steel. And it is a very good substitute for the steel in ballet radial tire, and it is used in the manufacturing of morning lines in the bulletproof vest. You saw the bulletproof jacket that army officer they wear that there, that is manufactured from your Kevlar, okay, and other protective clothing. So as I told you, they have lot of application at like this bulletproof vest. They wear this police officer or this driving gloves, walking boots, and this is basically they use for the army officer. And this military helmet, okay, they are also using. And this is a trade name or this is a copyright, that is a Kevlar reinforced bicycle tire they are using. Kevlar reinforced car tire also they are using. Fireproof clothing, car tire, bicycle. And this is very important application for the Kevlar, that is your cut resistance gloves. Okay, it is very difficult to cut these armite fibers. Okay, they are used in Boeing 757 and 767 planes. This Kevlar composite they make and use in this particular aeroplanes. And as I already discussed about this application, here I will just give you the few application like polyamide 12 polymer. They have this particular application in solar panel they use this, okay, and sports and luxury industry, electronics, and this is the fiber they are using. Nylon 66 in the form of tubing also they have used, as I told you, nuts and bolts. So this is just a pictorial diagram of all the application we have discussed, like clips, bags, and holders. These are the like gym bag or the sports bag. They are manufacturing. They are of this nylon fiber or these waterproofing clothes. Okay, they are manufactured from your armide or armide fiber or Nolex fiber. We can use them as a yarn also gear pulley, this kind of gear pulley. This is manufactured from your nylon 66. This is also from nylon 66. Okay. And these are the all the kinds of components that we manufacture from your nylon. Okay. So here I conclude the session of nylon or the polyamide.
Okay, ma'am.
And tomorrow I'll take your next lecture. Okay?
Okay,
Namita,
ma'am.
Yes.
do we have any assignment which we have to submit?
No, no. As os as still we have not instructed to do that.
Okay.
Yeah. Okay. Thank you so much.
Tomorrow, which topic you mentioned? Which topic we are going to cover, please?
Uh, okay. Wait, because tomorrow once I think Pawan will take or me. Just give me 1 minute.
But what topic? Maybe.
Yeah, yeah, I'm telling you the topic. Just give me a minute. Okay, tomorrow we will have cellulose and acrylic.
Okay, ma'am. Thank you.
Yeah.